Our goal is to develop an assembly language program tailored for the Intel 51 series microcontroller aimed at adding unsigned 8-bit numbers. This programming task will be accomplished utilizing either the student version or the evaluation edition of Micro Keil 5. Our aim is to add two unsigned 8-bit numbers, presuming that memory locations 04H and 05H hold the respective values. The added unsigned numbers are stored in memory location 30H. Let us see the procedure. Load the location 04H, direct address of R4, with a data 02H. Load the location 05H, direct address of R5, with a data 02H. Copy the data available in the location 04H to accumulator. Add the content across the memory location 05H to accumulator. Store the content into the memory location 30H. This is the complete assembly language program designed for the MCS-51 microcontroller to add to 8-bit unsigned numbers. Before proceeding with programming, it's necessary to install either the evaluation or the student edition of Micro Keil version 5 on your computer. Click on the Micro Keil icon available on the desktop. After opening Keil, navigate to the Project tab and choose New Vision Project. Create a folder to store all related files for this project. After creating the folder, Micro Keil will prompt us to select the microcontroller for programming. We will opt for the MCS-51 series microcontroller by typing 89C51 in the search window. Due to its evaluation status, the software permits only up to 2000 lines of code. A dialog box will appear, and we'll proceed by selecting OK. Next, choose New from the menu located under the File tab on the toolbar. Now let's start writing the program and enter the mnemonics as shown here for adding to unsigned 8-bit numbers. Once you've finished writing the program, it's time to save it. When saving, a window will appear displaying the startup.a51 file. Here, select the startup.a51 file and click on Save. Now, go to the Project tab and select Build Target from the menu. Here, we observe that the target hasn't been built due to an error caused by incorrect mnemonics entered during the program writing phase. While the ending is correct, the mnemonic add is inaccurate. It seems the accumulator is attached to add. To rectify this, we need to separate A from add and write add. A. After making this correction, we can rebuild the target. Wow, we have done it. Under the Debug tab, choose the option Choose Start or Stop Debug Session. On the left side of the screen, we find the register window displaying the corresponding content. But now it will not show any content. It will come into effect only after running the code. Simultaneously, in the disassembly window, The code begins from address 0000H reserved for storing operational codes. Adjacent to it, on the right side below of the screen, lies the Memory 1 window. By entering C0000H in the address section, we can view the operational codes corresponding to the entered mnemonics during programming. Additionally, we can open another memory window, Memory 2, and input D30H in the address section to observe the stored result. To execute the code, we initiate the Start and Stop Debug session, accessible under the Debug tab and followed by clicking Run under the Debug tab. Running the code alters the content of the registers, which becomes visible. That concludes today's video lecture session. We hope you found the content enjoyable and informative. For more enriching content, stay connected with our channel, iNet Tech Talk. Thank you for watching.